Here I'm going to show how to use the Vivado tool from Xilinx to create a package file that PartBuilder can use to get all of the pin data required for a giant Xilinx FPGA. So I just finished writing out the package file for the XCVU19P FSBB3824. That's the new, latest, biggest part from Xilinx. This one is a 3800 pins, and it's got 80 transceivers. So now I'm going to do, they have another package that doesn't have so many transceivers. It's got more I/O in the same device. So what we're going to do is we'll set that up. So we're going to do File, Project, New. Next, we'll call it Test XCVU19P. More I/O, just because I don't really know the name of it yet. Say Next. We're going to select an I/O planning project. We're not going to import I/O ports at this time because we don't need to. All we want is to get the CSV file out that describes the device. Say Next. So we're going to go XCVU19P in this filter, and it'll come down to the 4 devices that are available. So there's a -2, a -1, a -2, and a -1. And the FSVA is the one that has 22,000 ILBs and 48 gigabit transceivers. The one I built before was this FSVB, which has 1,760 ILBs and 80 gigabyte transceivers. So we're going to pick this one. The speed grade doesn't matter when we're building symbols. So the -1 is a speed grade, the -2 is a speed grade. So let's pick the -1, and we'll say Next. We say Finish. We'll close the old one. And now this takes a little while because it's such a giant part that Xilinx has to create the database. It has to read the database and create a picture of this part. So I'm going to speed up this step in the video. Okay, and so now Xilinx has loaded this part, and you can see just how big this is. It's got all these I/O banks, 1, 2, 3, 4. Every one of these guys is an I/O bank. So what we're going to do now is we're going to enable the Tickle console window so that we can do the write CSV. And what we're trying to get is a file that Xilinx produces called the package file, which you can get a text file from Xilinx on their website, but it doesn't contain all the data that is needed to really create a quality symbol. And so what we do is we just use the write CSV command, CSV, and I'm going to put it in my downloads file. And it's nice, it lets you tab complete here. So, and then I'm going to call it XCVU19P FSVA, and let's do underscores just because I like underscores better. So FSVA 3824.CSV. And it read it out, and now we can go look over there in that directory, downloads. You can see here's the one I wrote out before, and here's the one I just wrote out. And we can open it as a CSV file. And it has basically all of the pins. So if we go look down to the bottom, it's got 38, 32 pins in it. And every single pin is in here. And PartBuilder knows how to read this file. The other nice thing the PartBuilder can do is it has the pin delays in here, so the max trace and max trace. PartBuilder can read those and annotate your device with them. So if we spread that out a little, and then here's the I/O names for each pin. And this tells you what bank it's in. This is in bank 20, bank 19, bank 20. And so PartBuilder is going to make quick work out of this part. and we'll use it in the next step. Again, if you don't have access to Vivado, you would ask your engineer, who's going to be the lead architect for the FPGA here. An FPGA like this might take 10 people to design. So there's going to be someone on the team who you can liaise with, and you could tell them, hey, I need you to look at this video and I want you to do the right CSV to give me this XCVU CSV file that describes the I/O.